is Mike Abshire. I'm a Senior Application Engineer. Today we're going to be looking at the Stratasys V650 Flex. It's a new endeavor in technology for Stratasys. Certainly not a new technology, but new to Stratasys. So we want to start off looking at the machine. We're going to look at the technology, the machine itself, and the different materials that you can run in the machine. Stereolithography, sometimes referred to as SL, is a word that was invented in 1984. It was invented for the first patent application of 3D printing. And just for those of you that are into trivia, the word stereolithography actually means three-dimensional solid printing. Stereos means three-dimensional. I know a lot of people think it means two speakers, but it means three-dimensional. Lithos means hard or solid, and graphos is writing or printing. So it literally means three-dimensional solid printing. Stereolithography has been around for 30 years, and it's got a very wide range of applications, and it's very versatile. It does a very nice surface finish directly from the printer, and it has high-quality parts with high-quality detail. Looking at the stereolithography technology and how it works, this is a very simplified diagram of the SL process. It starts with an ultraviolet laser. And those of you that are into trivia, laser is an acronym for light amplification stimulated emission of radiation. And I just throw that in there in case you're in a trivia contest, you'll have the winning answer. So after it goes to the laser that generates the light, the optics module filters or separates the light to project only 355 nanometers. That's the wavelength of light required to harden the liquid photopolymer resin. Then you have the scanning galvanometers, and these are mirrors on servo motors that reflect and direct the laser beam for the XY axis motion. The laser is on the surface, and only the surface is solidified as it is drawn. So the platform raises up and down in the vat to position the Z-axis. So this is just an overall of kind of how the part of the technology works. So some of the challenges with stereolithography that are out there today is that we have a lot of aging systems out there. It's been around 30 years, so a lot of systems are getting old. We've got a lot of new suppliers with similar vat technology, but they're building smaller units with small resin trays. So it doesn't really support high production or high yield parts. And then we've got a lot of foreign suppliers coming over with larger machines, but they're really delivering unreliable parts and unreliable service. And another problem is the locked materials. Having your materials locked drives up the cost, while it also limits development of applications out there. So these are some of the challenges that Stratasys wanted to overcome. So they decided to be a little more diversified here if they took a multi-vat printer. So this printer is designed for an interchangeable vat. This allows you to use different materials and switch out the vat back and forth. The open materials and customizable parameters for tweaking will allow you to change your mechanical properties or change your build speed, as well as be useful for material development. Dependability is the key, and that is achieved by the simplicity of design. It is designed by users for users. So introducing the Stratasys V650 Flex. The V in here stands for vat polymerization. That's a designation from the ASTM F42 standard that defines additive manufacturing technologies. The Flex refers to flexible for open source material. So it's a large-scale system that gives you greater accuracy, gives greater choice, and lower cost with an open vat system that you can use any 355 nanometer resin in. Looking at some of the specifications, The build volume is 20 by 20 by 23. You can build 4 thousandths of greater build layers. You've got an adjustable beam size. The diameter will go down from 5 thousandths of an inch up to 30 thousandths of an inch. That means if you need to do some very fine detail, that 5 thousandths focus will get into small areas. Or if you're doing big solid parts, 30 thousandths, that just means instead of drawing with a pencil, you're drawing with a Mark-a-Lot, so you can get your part built a lot faster. The maximum drawing speed is 700 inches per second, and then you've got great X, Y, and Z resolution there. What's really key here, though, is the open vat system. Here again, customers can use any resin they want. We are providing the profiles for 4 commercially available DSM Somos resins. When we say profiles, this means we're giving the parameters in a package for 4 of the resins. You can still develop your own resin. You can still develop your own parameters, but we're putting these 4 starting out, and there will be more. It also has interchangeable vats, so you can have a full vat or a half vat in there. And where that comes into advantage is not everybody builds parts 23 inches tall, so if you had a half vat that only built 9.5 inches tall, you'd have a lot less investment in material in your vat in the liquid resin. So that comes in handy for driving cost. Also, this is built for production. This one has been built and tested at the Stratasys Direct for 4 years now. So this is not just a newcomer. It's been around at their facility for a long time, running 24/7. And here again, for the support infrastructure, Stratasys service, they already have a service structure in place. It's not like the 4 systems that are often plagued with reliability issues and unreliable service from competitive companies. Now, also we're partnering with DSM Somos. They are a world-class resin supplier. They've been in business for 30 years, supplying resins in this market. So they hold quite a few key patents and some of the best resins around, if not the best. Operational factors, so it's a pretty small footprint when you look at a big machine like this, 55 by 50 inches, 87 inches tall. You don't need any special site preparation. It's going to run on 110 single-phase outlet. It also has a UPS built into it for short power outages, and it has some smart controls built in so you can restart the build even if you have a longer power outage. It's also equipped with an interface to communicate with a database for performance monitoring. This is really key when people are doing their process controls, things like that, looking at history of the machine. So let's take a look real quick at the SL materials. Stereolithography materials are photopolymers. We're all familiar with engineered plastics. Engineered plastics, we use it in our cars, we use it in the chairs we're sitting in, our telephone. Those are all engineered plastics. Things like ABS, polycarbonate. And when you think of thermoplastics, think of softening. I'll give an example down here on the graph. A chocolate bar. You can take a chocolate bar, you can melt it, you can reshape it, you can melt it and reshape it as it cools back and forth. The same is true of engineered plastics. All the plastic bottles, things like that we're familiar with, they can recycle them and they can remelt them and use them again. Photopolymers are a little bit different. They are a thermoset material. This is important for some of your applications because think of it like the cracker down here. You can make all your ingredients to make a cracker, but you can not get all the ingredients separated back out again. So photopolymers for stereolithography cannot be reheated and melted to shape differently. This is kind of important on some of your applications, so therefore it doesn't melt for high temperature use. It lets you do injection molding and some other very unique things that you could never do with the engineered plastics. We talked about 4 materials that we're going to offer with DSM Somos, and here are the 4 materials. Somos Watershed. It's been the most popular stereolithography resin for over 10 years, and that's due to its clarity and its high water resistance. In fact, I believe it's still the most water resistant resin in the marketplace. If you're looking at one generic resin, this is highly recommended for use. The next one we'll look at is a Somos Next material. It's tough, durable, impact resistant. It also is for general use parts, but the impact resistance on this particular material is really pretty amazing. And I believe Somos has about 20 different materials available out there for numerous applications. But some of their special, and they're all specialty applications, and here's some of their specialty applications. The Somos Element. This is strictly for the investment casting applications, antimony-free. That means there's no heavy metal in it that can contaminate some of the alloys that are being cast. Also, the low ash content is necessary for when you're burning these patterns out. Remember, they don't melt, but you can burn the pattern out of the mold with low ash and then you pour the metal in, and that's what becomes your casting. The Somos Perform material, this is a ceramic composite, high temperature resistant material. And this is really great for all those applications like injection molding, under the hood automotive uses, even if you're going to be doing some plating on it. This is really good because it doesn't have being ceramic, it won't have the stretch and growth with the heat that you might get from some of the plastics out there. So they have some really great materials that Somos highly recommended. So we're taking a quick look at the technology, the stereolithography, the machine. I want to just reiterate it's a large-scale production, interchangeable vat, tested out there in the field. It's reliable, open-source material, but we do offer parameters from DSM Somos, which is a world-class supplier. So we've covered all the things we wanted to cover. Just one last thing. If you want to learn more about this or any of our products at CATI, you can go to our website, and there's many things you can look at here. I've listed them here for media resources that are available. That really just about covers it in a nutshell.